Hello, everyone. Good morning, evening, and afternoon. Dear authors and invited guests, I welcome you to Technical Session 10F. My name is Amol Dhamdere, and I will be moderating this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is a great pleasure to welcome all of you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026. The 11th edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom from the 9th to the 11th of April in 2026. I hope you will be enjoying the knowledgeable and interactive sessions we have planned throughout the day. In this particular session, we will be having 10 presentations where each presenter will be given 10 minutes for presenting and 2 minutes for questions and answers. On the completion of around 8 to 9 minutes, I will be raising a gentle reminder as well. There is another request to all the participants that all of you please stay connected with us until the closing remarks are given. And if you have any queries or updates, you can write it to me in the chat box below. Just before we start the session, I would now like to introduce our session chairs for this session. So our first session chair is Professor Mohammad Mehdi Rahman Rana. Professor Mohammad Mehdi Rahman Rana is an assistant professor in the Department of Computer Science and Engineering at the Bangladesh Army University of Science and Technology, Khulna, Bangladesh. With approximately 9 years of experience in academia and research, his work focuses on computer vision and image processing, machine learning applications, data and text mining, IoT and networking, and document image analysis. Sir, we welcome you and I request you to give us your opening remarks.
Thank you, Amang, for giving this excellent introduction. Good morning. I am Professor MD Mehdi Rahman Rana from the Department of CSC from Bangladesh Army University of Science and Technology. This is today my pleasure to welcome you to technical session of 11th International Conference on Information and Communication Technology for Intelligent Systems, which is ICTIS 2026. Today in this session, we will cover diverse and emerging topics in intelligent systems, including machine learning, data systems, and optimization techniques. I kindly request all presenters to strictly follow the time limit that our session moderator Amang discussed about. And I also encourage active participants from the audience during the Q&A segments. Thank you.
It's great to have you with us, sir. Our next session chair for today is Dr. Kirti Vanzare. Dr. Kirti Vanzare is currently working as an associate professor in the Department of Computer Science in Vishwakarma Institute of Information Technology in Pune, India. She has 22 years of teaching experience. She has presented papers in many national and international conferences and published articles in many international journals as well. Her research areas are wireless sensor network, AI, IoT, and image processing. Ma'am, we welcome you today and I request you to give us your opening remarks, please.
Good morning, all. Thank you, dear, for giving such a nice introduction. I welcome all participants to this conference, and let's see the technical journey ahead with lots of state of art techniques that we'll get to know today. So I wish all the best to all presenters. Thank you for invitation. We'll start with the sessions. Thank you, sir.
Thank you so much, ma'am. It's great to have you today. We can move on to the next presentation that we have planned, which will be done by Lanja Aziz Abdel Kadir from the Tishk International University in Iraq. And the title of the research paper is Optimizing Smart Home Scheduling Using Enhanced Meta-Heuristic Algorithms Under Electricity Constraints. Ma'am, I request you to kindly unmute yourself and start presenting, please.
Thank you. I share my screen.
Yes, ma'am, please. Facing any problems?
Yes, just a minute.
Sure.
Okay, now yeah, can you see my screen?
It's still loading. Yes, now your screen is visible.
Okay. Uh, just okay. Good morning, everyone. My name is Lanja Aziz, and today I will present my research title, Optimizing Smart Home Scheduling Using Enhanced Meta-Heuristic Algorithm Under Electricity Constraint. In this research, I focus on improving smart home energy scheduling using advanced optimization algorithm, especially under real-world electricity limitation. The concept of smart home has rapidly evolved with the development of technology. One of the main benefits of smart home technology is its ability to improve efficiency by scheduling under limited time. And the problem addressed in this research can be summarized in four key points. First, increasing energy demand, the rising of smart home technology has led to higher electricity consumption, especially during peak hours. Second, dynamic price means electricity price vary throughout the day, making cost management more difficult. Third, regional consumption constraints. In region like Kurdistan, because I am living in Kurdistan, there are a specific limit. For example, 40 ampere for one region house, making energy management more complex. Finally, traditional scheduling methods are not capable of handling this dynamic and constrained environment. Therefore, there is a strong need for advanced optimization based scheduling system. Our first objective is to develop optimization algorithms that schedule household appliances in a way that minimize energy consumption and reduce energy cost. Second, to incorporate energy supply constraint into the optimization model. To modify and enhance existing optimization algorithm to improve performance. The fourth objective is to implement a cycle rebounded mechanism to management scheduling conflicts. This mechanism ensures that if the start or end time of an appliance fall outside the allowable window, it can be bounded back within the schedule limited. And finally, to start and evaluate the performance of the all algorithm under different scenario. In my research, I used three different scenario. The main contribution of this research are as follow. First, incorporating the constraint of limited energy availability. The second contribution is the enhancement of the single candidate optimization by integrating the levy flight mechanism. This modification improves the algorithm ability to explore the solution space by making larger and more efficient jump, which help it find better solution. Our third contribution is the improvement of both the Marin predict algorithm and FDO using OBL. OBL enhance the exploration capability of this algorithm by generating candidate solution with their opposite. In this slide, I include several related work, but due to limited time, I can explain all of them. If anyone is interested, I would be happy to share more detail by email. In this study, I tested 8 algorithms, included both original and modification version. These include PSO, BAT, FDO, SCO, and MPA. Additionally, I apply enhancements such as opposition-based learning to FDO and MPA and level flight to CSO. This modification aimed to improve exploration and avoid local optima. The fitness function calculates the total electricity cost. We can see this equation, PT is the price of electricity at hour T, CE is the energy consumption of device I, DIT is the binary indicator of whether device I is operating at hour T, FTCE is the fraction of time where the operating time at T of device I is the end or start time. Simultaneous energy consumption constraint. Calculate operation duration on time for each device over 24 hours period. Store the on time of each device in a 24 hours array. Calculate and edit the energy consumption in each hour in the 24-hour array. Determine if simultaneous energy consumption exceeds the set threshold of each hour in the 24 hours array. If energy consumption of a candidate solution exceeds the threshold at any given hours, then discard that solution. One of the key important point in this search is the cycle rebounded concept. You can see in two equation. If a device schedule exceeds the 24 hours boundary, it is rapid back within the valid time management time range. This ensure contribution and valid schedule without violating time constraint. For example, if a device is scheduled at hours 30, it is converted to hours 6 by subtracting 24. This mechanism allows flexible scheduling while maintaining visibility by using two equations for positive or negative, if depending on this. Okay, and we in this model use several important parameters. Working duration define how long each device operates. Energy consumption represent how much electricity each device uses per hours, because depending on the consumption is changed. Electricity price, the cost of electricity at each hours. We said that depending on the hours we change it change the electricity. We have define a set of parameters that are constrained for all algorithms, such as repeated of 50 times, iteration of 1000 times, number of particle on search agent 150, and finally the time limited between upper and lower time for between 0 and 24 hours. And I use 3 different scenarios. Result on discussion. The slide shows the configuration of 20 devices used in the research. Each device has a specific energy consumption rate and operation time, because we said that every device needed different energy and different time to operation. In the results section, I evaluate the algorithm under 3 scenarios: 6 device, 10 device, 20 device. For each scenario, I analyzed minimum cost, average cost, standard deviation, and scheduling behavior. In the first scenario, with 6 device, we observe that the marine predict algorithm consistently achieves the lowest cost. The enhanced version with opposition-based learning improve performance, but bad algorithm shows the weakest performance. We can see in the result. Overall, in all of the algorithm, modification algorithm perform better than the original version. This line chart illustrates the distribution of the cost of energy of each algorithm.
Excuse me, ma'am.
Yes.
Just a reminder, you have 2 more minutes of presentation time left.
Okay,
Thank
okay,
you.
sorry. The output of the marine predict algorithm is in both of its form, while bat algorithm score is the highest cost and therefore the worst result in the scenario. And this chart illustrates the minimum cost obtained for each algorithm and difference between them. As can be seen, the minimum cost between the algorithm marine predictive algorithm and simple form or with the opposition-based learning applied to it, while the highest cost for the BAT. And like above, we have a standard deviation. Standard deviation of the cost obtained from the 50 runs has been calculate for each algorithm to be able to see the consistently in the output of the algorithm. This also shows the reliability of the algorithm to give the same or near the same result when applied multiple times. And we can see in this table average cost, standard deviation, minimum cost for all of them. Marine predictor algorithm for both version have a best result, but and we schedule the time depending on the skills devices. We have repeated our test using higher number of household devices, 10 device and 20 device, to observe whether complexity of the device affected the output or not. We can see for 10 device have the same MPA with BL is the best result. And when we use, I can't continue, I can't share a result for 10 device and 20 device, but for all of them, bad algorithm is the worst and MPA is the have best result, minimum cost. And in the final, in conclusion, this research investigate 8 optimization algorithm for smart home scheduling under electricity constraint. The result shows that incorporating constraint in is essential for realistic solution. Enhancement like levy flight, opposition-based learning, significantly improving parameter by avoiding local optima. Among all algorithms, the marine predictor algorithm and its enhanced version consistently achieves the best result. On the other hand, the bad algorithm shows the weakest performance. Thank you for your attention. I am happy to answer any question. If anyone needs the result, I can share with them by email. Thank you.
Thank you so much for your presentation, ma'am. I now request our session chairs to ask any questions they might have. Professor Rana, do you have any questions for our speaker?
Okay, Lanja, that was a nice presentation and
Thank you.
quite an interesting one. So I have one question for you, which would be, so according to your studies finding, so what you think is the specific best modification that allowed your algorithm to consistently outperform the other algorithms that you mentioned there? Can you state that?
Sorry, I can't hear you. So sorry.
Ma'am, he
Can
wants to ask that what was one specific modification that you made to your algorithm which helps it outperform all the others?
yeah, and I did 3 modification. One of them opposition-based learning for FDO and MPA, and another one apply levy flight for CSO. But when I apply opposition-based learning for MBA, great result, and my result is high. I mean that my minimum cost when I use it opposition-based learning apply MPA.
Thank you. And in the future, try to explain your methodology with figures. That would be nice.
Thank you.
Dr. Vanzare, any questions for our speaker?
Yes, very nice presentation. And I hope
Thank you.
whatever solution that you found may solve your constraints. I just want to know, in first slide you said that the in smart home the electricity consumption increases in peak hours. So like I'm not getting in smart home the peak hours and that concept. Can you just brief about it once again?
Sorry, can you repeat it? Sorry, presenter,
You
can you?
said there is a limitation that in peak hours, in smart home, the peak hours, the electricity consumption increases. So I just want to know how it is possible that, what do you mean by peak hours at smart home?
Yeah, yeah. Because we have we need a limitation. We have because as I said. The concept of smart home has rapidly evolved with the development of technology. We use a lot of energy, and for scheduling this thing, we need a highest better solution. I use optimization because optimization use the good for complex problem. In my mind, a smart home one of the complex problem because I use it and I use it this optimization. I want to reduce the cost of electricity as we say. For example, I am living in Kurdistan. In the Kurdistan, we have a lot of problem for electricity because we have a limited energy, and sometimes during the day we didn't have electricity. We need to reduce cost and reduce for using a lot of we have electricity during day.
Any more questions for our speaker?
Thank you.
No, sir.
Okay, thank you so much for your presentation, ma'am.
Thank you.
Before we move on, I would like to ask Mrs. Hilasaka, did you manage to fix the problem?
Thank you for attention.
Thank you so much, ma'am.
Thank you. I resolved the problem, and
Sure, ma'am, you can
I
try
can start now.
sharing the screen. Yes,
Okay.
ma'am, you can do it.
Okay. Can you see my presentation?
Yes, it's now clearly visible. You can start presenting, please. Thank you.
Okay. Thank you. Mhm. Um, Okay. So,
Ma'am, you can click on the slideshow button. It will put the presentation in full screen. Yeah, now it's great.
okay. Good evening, everyone. Everyone. Good. Today, I will present our research entitled Dimensionally Reduced Linear Embeddings for Sonoscape Data Classification with Active Learning. This is the content I have prepared for this presentation. The problem is at first, okay, the problem with Sonoscape data is the large amount of time required to label audio recording collected from nature. This recorded sound present, for example, overlapping signal, noise, and can range from hours to even months of recording. The main challenge ecologists face when labeling audio segment in the time is the time required to perform this task, which is directly related to the complexity of the sound reflected in overlapping signal and noise. Now I will present our methodology as a solution to this problem. This is our proposed methodology. The first step is preprocessing. In this stage, spectrograms are extracted as graphical representation of sound activity. The idea of preprocessing is to highlight the characteristic of sound within spectrogram, which usually exhibit texture patterns of sounds. In this stage, CNN architecture are adapted and trained so that it becomes possible to extract embeddings from the audio files. In the design of the CNN adaptation, dimensionality reduction of the embeddings is included. This idea was proposed so that after training the CNN, it is possible to extract compact and semantically meaningful embeddings. After training the CNN models, and together with the extracted embeddings models are trained within the active learning framework. In this stage, classical query strategies such as loss confidence and entropy, among others, were tested. For the experiment, pre-trained embeddings such as Burnett, Jamet, and Google Perch were also included. Finally, classification metrics are used to evaluate the trained models and how they interact with the query strategies employed. Now I will talk about the result. In the supervised learning context, the adapted models that achieved the best performance were ResNet, DenseNet, and Ception. Okay. For pre-trained models, the best results were obtained using embeddings from Burnett combined with a random forest model. Graphically, in the active learning context, over 10 iterations, these were the result obtained using embedding extracted for the adapted models. Okay. Summarizing, per dataset, these were the best results achieved by combining embedding extracted from the adapted models with the last confidence query strategy. Now I will discuss the conclusion and future works. We proposed a CNN-based embedding extraction method that improves soundscape classification. By integrating dimensionality reduction into training, we obtain compact and highlight discriminative representations that outperform traditional methods. We also show that embedding quality is critical. High quality embeddings enable strong performance even with simple models, especially in low-level scenarios. Thank you for your attention.
Thank you so much for your presentation, ma'am. Professor Rana, do you have any questions for our speaker?
Liz, did you show any comparison with current systems.
The comparison in current systems,
Current
indeed.
studies. Did you, for your methodology, for your related works, you mentioned some papers, right?
Yes,
Yes, did you compare their results with yours?
I compared my result with the paper referenced aquí with number 5. Okay, the comparison is directly. In this case, for example, the authors extracted embeddings for same for the same case. Ta. Um, eh, and we have a comparison the result. In this case, the authors using ResNet 50, ResNet or CNN with other combinations um, in the
Did
same data set.
you took these results from the papers, right?
My result is over in
No, in
comparison.
the mentioned the mentioned like the ResNet 50, 0.52. This you took from the paper, or you run the experiments on your system.
Mhm.
Did you run the experiments on your system, or you have taken the results from the paper, or in here the CNN DO, these ones, the bottom ones? Yes.
Uh-huh. That's I don't understand your question. Sorry.
I said, did you run these experiments on your system, or you took these results from the papers, the bottom ones?
I execute the experiment with the specific information in the paper. Okay, but I execute
Okay,
the
okay,
experiment.
okay. Then, okay,
Mhm.
okay. Thank you. That's all I wanted
Thank
to
you very
know.
much.
Dr. Vandare, any questions for our speaker?
No questions from my side because I found her presentation itself self-explanatory. Thank you.
Mm,
Okay, thank you, ma'am. Thank you so
Thank
much for your presentation, ma'am.
you. Okay.
We can now move on to the next presenter for today. So our next presenter is Purva Trivedi from the Indore Institute of Science and Technology in India. And the title of the research paper is a Review of Modern Energy Harvesting Strategies, Comparative Insights and Performance Evaluation. Ma'am, I request you to kindly unmute yourself and start presenting, please. Okay, I think she hasn't joined us yet. We can move on to the next presentation, which will be done by Shubham Sahu from the University of Engineering and Management in India. And the title of the research paper would be Session Level Imposter Detection Using Mouse-Based Behavioral Biometrics. Sir, are you present in this meeting? Any of the co-authors as well? Okay, I think we have to move on to the next one. So our next presenter will be Tamil Mani M from the Hindustan College of Art and Science in India. And the title of the research paper is Smart System for Identifying Leaf Disease Detection Using AI and Computer Vision. Sir, I request you to kindly start presenting, please.
Hello, sir. Hear me?
Yes, sir, I can hear you, and your screen is visible as well.
Sir, first of all, thank you for this giving this opportunity. Hello, sir. Hear me now?
Yes, you are audible, sir. You can start presenting.
Sir, my project name is a smart system for leaf disease detection using AI and computer vision. The main goal is agriculture based on a project. This is the leaf disease. We can find out the using AI. Agriculture is very important for us, but plant disease are the big problem. Every year farmers lose lots of crops because the disease. Right now the checklist manually, which takes lots of time, often wrong. So my project using AI and computer vision solve this. It helps farmers identify disease immediately just by taking a photo. And our project has a main goal for first we an automated detection process using AI, and second we are high accuracy so that diagnosis is always correct. The system must be enforced and given real-time results. Finally, our goal is to make the technology and simple, affordable for every farmers. And the technologies we have used on Python and main language with OpenCV for processing an image. The brain of our system is CNN algorithm using TensorFlow. The architecture is very simple. We can take an input image pre-process to remove noise, and then our AI model extracts features to classify disease. Everything happens in real time. The data set and training is for the data set we can use plant village libraries which has thousands of leaf images to make a model very smart. We split the data 80% of training and 20 for testing. We also data which means is rotated filtered the images so AI recognize disease even if a photo taken at a different angle. This makes our system very real time farming. Finally, let's talk about the performance and the future. Our system is not accurate with a 95% of 95% rate, also incredibly fast, giving results under the on 1 second. Looking at future scope include building a mobile app, farmers adding treatment and recommendation. We want to the system to not tell farmers what your disease, but also how to cure. Yes, sir. That's my presentation.
Thank you for your presentation, sir. I now ask our session chairs. Professor Rana, do you have any questions for him?
Uh, yes, what was the name? I forgot. Can you say the name, Aman?
Sir,
Yes, sir. Give me just. Okay, you can continue, sir.
Okay, that was a nice presentation, but there are some uh, missing information which should be. Did you include any background study or results in your presentation?
So, just before he answers that, I would like to tell you the title of the research paper once more. So, the title was A Smart System for Identifying Leaf Disease Detection Using AI and Computer Vision. So, that was the topic.
Thank you. Thank you, Aman.
okay, sir. Thank you. Sir.
Okay, what was your contribution in this research?
So collecting images, disease relief images, sir.
But you mentioned that you used already made a data set.
Yes,
Did you use
we are
did you
collecting the
use data
disease.
set or collect?
Yes, sir, I'm collecting the data sets, sir. Different kinds of data sets are collecting. Yes.
Can you go to the slide where you mentioned the data set?
Yes, sir.
Okay, here I can see that you have trained your model on plant village dataset with 50,000 labeled images.
Yes, sir, you can train a CNN model.
So did you collect your dataset or did you take data from plant village dataset?
Yes, take from a plant village dataset, but tested different kinds of images, real-time images. You can use project this types of plant village dataset.
You also took real life images, real time
Yes, sir.
images.
Yes, sir. That is
Okay.
also I took.
Then you should mention it in your presentation. Also, I can see you did 80-20 split for train and validation. Did you not test your model with any data?
Sorry, sir. Repeat.
Okay. Do you have any results? Can you show me your results?
Yes, so the
It's not have to be on the slide. You can also show me otherwise, or you can just speak the results. You can just mention the numbers. That would also be okay.
sir, you're asking the accuracy score or what?
Yes, yes, yes. What was your accuracy, or what was
That's
different
the
models? Did
accuracy
you
score
did you
is not
train different models or not?
not it, sir. Yes, the
Okay, it's fine. We that if you currently if you don't have, then it's okay. We can just move on.
okay, sir. Thank you.
Dr. Vanzare, do you have any questions for our speaker?
Yes, actually, I'll just give few suggestions. Like while giving the presentation, you should talk about the data set that you are using, and you should talk about your results perfectly comparing with the other systems that are already in existence. So that was missing from this presentation. That's it from my side. Nothing.
Okay, thank you so much, ma'am, and thank you, sir, for your presentation. We can
Thank
now
you,
move
sir.
on. Yeah, we can now move on to the next presentation today. So the next presentation will be done by Tega Wetde Vrijite Kien Tega. I apologize for any mispronunciations. From the University of Nazi Boni in Burkina Faso. And the title of the research paper is Toward an Interactive Data Warehouse Design Based on a Federated Ontology. Ma'am, I request you to kindly start presenting, please.
Hello, do you see my screen?
Yes, ma'am, your screen is visible to us.
Great, thank you. Good morning, everyone. My name is Tegawende Brigitte Ketka. Thank you for the opportunity that you give us to present our paper titled Toward an Interactive Data Warehouse Design Based on a Federated Ontology. I'm at the University of Nazibone in Burkina Faso. Our presentation will follow the different steps. After introduction, we talk about review work objective and methodology and conclude with a conclusion and perspective. In introduction, can say that our work is motivated by the following concept. We have data warehouse and online data analysis, all which are the essential pillar of business intelligence. Also, decision makers are always less involved in the design of a data warehouse. However, analytical needs frequently evolve over time, which require better consideration of decision maker requirement. We are motivated of the rise of big data, where data sources have become more heterogeneous and scalable, causing incompatibility in data warehouse model. The different design approaches proposed in the literature to solve this problem each have limitations. We believe that an approach combining data source and requirement is ideal. Now, what about objective? The general objective is to automatically derive multidimensional schema from existing source while integrating the need of the end user with an automatic adjustment of dimensions and hierarchies. Specifically, we want to use existing data source to build a federated ontology. Also, we want to generate a constellation schema of a data warehouse from a subdomain of this ontology. And third, update the ontology and the data warehouse schema to integrate the new hierarchies. Now, the literature review allow us to outline some limitation and propose a methodology for the design and the evolution of data warehouse. The methodology consists of three complementary steps. The first step of our methodology, titled Federated Ontology Construction Approach. This step of the methodology objective is to take into account all types of data source, like structured and unstructured source, using the model merging technique. This step is illustrated by the schema that we have data source like context ontology. The different data source will be mapping to an local ontology, some local ontology, and the different local ontology will be fused to generate our global or federated ontology. Now, for the case of unstructured data source, the literature recommend proposing Git for construction. And now, we think we have proposed to examine the approach now lead-oriented design (OD), which help us to acquire knowledge from a textual corpus. The illustration with unstructured data source, we have proposed to generate a pivot format like a text format. With this pivot format, we are use some technical like LLM method to extract ontology concept and use them to generate the local ontology for this case. In the case of structured data, in the literature, data literature propose reversing engineering technique that have some limitation, like to take account semi-structured data. And the approach that we propose is to use the different associated interface of relational source to generate a XML schema in which we are used to extract the semantic of a relational database, the semantic of a relational database, and use some rule to generate a local ontology. And if we have a different local ontology of each source in the kind type, we are going to use algorithm of fusion to generate our federated ontology. Now, the step number 2 of our methodology title an approach for selecting a subdomain of a federated ontology to generate a data warehouse schema. Now, the first objective of this step number 2 is allow the decision maker to select a subdomain of the ontology in order to limit the analysis to the noun lead for the desired context. At this stage, the literature proposed several approaches that treat the ontology as a graph. We have also semantic approach. In this step, we believe that the combining both approach can lead to more accurate results. The second objective of this step is to allow the decision maker to automatically generate the data warehouse schema. And several studies are proposed to use the model-driven approach MDR, but each has its limitation. And in order to ensure the evolution of the different transformation of the model, we propose to use this approach MDR to derive automatically our schema like conceptual, logical, and physical from the model semantic that is our subdomain ontology through transformation rules. And the Shaman mentioned it with our global or federated ontology. We are going to permit the decision maker to select the subdomain and to generate his data warehouse. And this approach is unified because it allows the merging of the design step and the ETL process. Step number 3 of our methodology titled an approach for maintaining the data warehouse. The first objective of this step is to ensure the synchronization of update between
Excuse me, ma'am.
data source. Yes?
Just a reminder, you have 2 more minutes of presentation time left.
Okay.
Thank you.
Okay, thank you. Update between data source and the federated ontology. In this, we propose to use the approach of Eflin and al. to take account entire ontology relationship and the life cycle of instance. The second objective is to update the data warehouse schema and generate query for OLAP analysis based on natural language. In this case, we propose to extend the approach of lucid thought that construct dimension hierarchy from factual data, and we are going to complete the data of the data of the dimensions. Now we propose to explore the use of LLM, large language model, to translate natural language query into MDX instruction to facilitate the interaction with the data warehouse, even a decision maker non-expert. In conclusion, the literature review has allowed us to underline some limitation in ontology and data warehouse domain. This leads us to propose a methodology that permit to take account the building of ontology with heterogeneous data source. We have the construction of a data warehouse through a hybrid unified automated approach and a OLAP analyze through query based on natural language. Looking away, our future work will consist to develop each approach proposed in the methodology and test them with some real data. Thank you for your attention.
Thank you so much for your presentation, ma'am. Professor Rana, do you have any questions for our speaker?
Okay, so one thing nice about your presentation was your methodology was quite detailed, but try to wrap it up faster in the future. Also, one recommendation same recommendation for you, which would be to include the results section, also compare the results with current studies. Okay.
Okay, thank you.
And I have a question, which is in a federated system, do you know that there are conflicts across distributed oncologies? Do you have an idea about that? Conflicts, do you have the idea of conflicts across distributed oncologies in a federated system?
Yes,
If
because we can have conflict in the generation due to the heterogeneity of the different data sources.
My question is that did you take any steps to resolve the conflicts?
Yes, we have proposed some algorithm to align the different concepts and to compare the different concepts with an certain accuracy and align them and try to discover synonymy and other word which is near of certain concept.
Okay,
So
okay.
we
Thank
have
you.
proposed some algorithm.
Okay, thank you. Thank you. Thank you for your
Thank you.
presentation.
Thank you.
Dr. Manjare, any questions?
Yes, the presentation was nice. I just want to know, you have worked on interactive data, right? Data warehouse. So what was the size like that you have considered? Or it could be of any size and it could contain any kind of data.
Can you repeat your
Yeah, my question is that you have said data warehouse, you are going to work, like you said you are going to work on interactive data warehousing. So I just want to know data warehousing in the sense which kind of data you have considered, or any type of data is applicable to your solution.
Yes, every kind of data is possible because we have merging each type of data in our ontology, and this ontology is the base that the decision maker use to build the data warehouse. And he can select the subdomain of the ontology, which is our global data source. So we can say that all type of data source can be used to generate the data warehouse.
Okay, thank you. Thank you, ma'am.
Okay, thank you.
Okay, thank you so much for your presentation, ma'am. We can now move on to our next presentation for this session. So the next
Okay,
one will be,
thank you.
oh, thank you so much, ma'am. So
Okay.
the next presentation will be done by Ambati Abhinavya from the National Institute of Technology in India. And the title of the research paper is Wavelet-Driven Intelligent Model for Multi-Class Breast Cancer Diagnosis. Ma'am, I request you to kindly unmute yourself and start presenting, please. Okay, I think she is not present with us at the moment. We can move on to the next one then, which will be done by Apeksha Pandurang Mujumare from the Pune Institute of Computer Technology in India. And the title of the research paper would be Word Level Plagiarism Detection Using Cosine Similarity, Euclidean Distance, and Manhattan Distance Metrics. Ma'am, I request you to kindly start presenting, please.
Am I audible? Hello, am I audible?
Yes, you are.
Just a minute, I'm sharing my screen.
Sure.
Is my screen visible?
Yes, your screen is visible. You can start presenting, please.
Yeah, so good morning, everyone. My name is Apeksha Muzumle, and today, along with my co-authors, we are presenting on word-level plagiarism detection using cosine, Euclidean, and Manhattan metrics. So, our work focuses basically on comparing different similarity techniques to detect plagiarism more effectively. So, especially in some cases when it is paraphrased. So, starting with the abstract, our work focuses on detecting plagiarism at the word level using NLP techniques. So we used TF-IDF vectorization and n-grams to convert text into numerical form, and then we compared it based on three similarity metrics, which are cosine similarity, Euclidean distance, and Manhattan distance. So basically, what we concluded from our results is that cosine similarity performs best, which achieves around 88 to 92% accuracy for direct plagiarism, and also better performance for plagiarized text. So, additionally, when we used n-grams for doing this, the accuracy improved significantly. So, introducing today, with the rise of ChatGPT and AI tools, generating content has become very easy. So the risk of plagiarism has also increased. It has become very hard to know whether the text is plagiarized or whether it's written by the individual. So traditional methods like string matching, etc., fail because the text is just paraphrased and it is taken from the AI tools only. So to overcome this, we used vector-based similarity methods, which through which we convert the uh, text into vectors, and we mathematically compute whether it is matching to any of the data sets. So our goal is to identify which similarity metric works best for plagiarism detection. Talking about the literature review, from existing research, we found that TF-IDF with cosine similarity is widely used, and n-grams also help capture the context better, and cosine similarity performs very well in high dimensional spaces. So, as mentioned in our paper, cosine similarity is dominant because it is scale invariant and works well with sparse vectors. So, the gaps we found in the existing research was there was a lack of direct comparison between all these three metrics, because there are various tools, but we never know what comparison, like what similarity metric they are using to give those results. So we are performing a comprehensive view based on all the similarity metrics. And there is also poor detection of paraphrased content. So for that, what we did is we used n-gram analysis, through which what we can do is we can group the words in certain number of words, like group the whole corpus into certain number of words, and then we can make the vectors out of it. So paraphrasing can be detected better. And no threshold optimization is provided, meaning that we have provided the functionality to adjust the threshold according to user needs, whatever he requires. So that is our customization provided. And the proposed methodology. So what we are doing is we are having a input text, and we are having some references already stored, or you can also give the references. Then we do the pre-processing on the text. So pre-processing basically is we do the tokenization, like converting the whole corpus, like whole sentences, paragraphs, into simple words. Then we remove all the stop words out of it. So stop words are basically the words which are repetitive and which don't carry much meaning, like and all those words which we remove. And then we did lemmatization, which is converting the word into root words. And then we applied TF-IDF vectorization. So what TF-IDF is that term frequency, which means we count the frequency of all the words present in our corpus. And IDF is inverse document frequency. In this, what we do is the words which occur more frequently get less importance, and the words which occur less frequently get more importance. So the meaning can be uh, understood out of it. And then we applied the similarity metrics, all the three similarity metrics we applied. And based on the threshold is basically the percentage of plagiarism, above which, if we have our text plagiarized, then it will flag it as plagiarized. If it is below that, then it won't flag it as plagiarized. So the algorithm, uh, just a minute. Yeah. So this is our algorithm. We are having the input documents, then we do the text pre-processing, then we split the documents, then feature extraction methods we can apply, bag of words, TF-IDF, and n-gram analysis, any of them. And then we apply the similarity measures like cosine, Euclidean, Manhattan, and then we get the scores out of it. So moving on. Yeah, so these are the formulae used. This is Euclidean distance, which basically what it does is it takes the shortest distance between 2 points, that is a diagonal distance between 2 points. So whatever text we have converted into vectors, we are applying this formula, and we are checking if uh, the distance is more or less. If the distance is less, the text is more related. If it is more, it's less related. And in Manhattan, what we do is we don't consider the shortest distance, that is the diagonal distance. We consider the horizontal and vertical distance between the vectors. And this is our cosine similarity, which basically considers the angle between the vectors. So the the lesser the angle, the more related the two texts are. And these are our results, whatever we found from a lot of texts which we tested on. We put some data sets also. We had given data sets at like some data at runtime also. So based on that, this is what we found out. And this is the conclusion that cosine is more robust and scale invariant, while Euclidean is sensitive to vector length, and Manhattan gives some moderate performance. So cosine metric is overall the best metric. So this is basically a quick demo of our project. So here you can choose the number of words for n grams. So let's suppose I pick 3 words, and in our data set, in our code, if we see, a minute, here we have given the data sets. So the exact text I have copied and pasted it here. So it shows 100% plagiarized. Now, if I paraphrase it a bit, paste this paraphrased text. It is still detecting it to 61.8%. All thanks to this n-grams, through which we can improve the calculation percentage efficiency for paraphrased text also. So that's all from our side. We are open to any questions.
Thank you so much for your presentation, ma'am. Professor Rana, do you have any questions for our speaker?
Yeah, that was a nice presentation, and I appreciate your demonstration of your project. Uh, I have the same recommendation for you that in future you please include the comparison with current studies. And my question to you would be, you mentioned using both TF-IDF vectorization and n-grams, right?
Yeah.
Okay, so could you clarify that DG or which n values you find most effective?
Uh, it's like more the value of n we consider. It considers more
Yes.
words in a single go, so it's very hard to do the analysis on paraphrased text in that sense. So lesser the value of n, we can detect the metrics clearly for non-paraphrased text. But if that, sorry, for paraphrased text, but if it is not paraphrased, then more value of n also works. So it's conditional.
And did you do any analysis on that the higher order of the value n, does it significantly increase the computational overhead, or how much it does or doesn't?
So basically, for a higher value of n, so it would be the text should be like exact text match should be there for higher value of n to work. If even if we tweak it a little bit, if the value of n is higher, it would be very hard to detect what the whether it is plagiarized or not.
That how is and how much effect does it leave on the computational overhead? Like computationally, is it how much is the complexity proportional to your n value? Did you
Mm,
do
yeah,
any
so the
analysis on
complexity
that or
would
not?
increase because
It would increase linearly or exponentially, or what? Do you know, or did you study on that?
no, I'll have to study more on this.
Okay, that's fine. Okay, and that's it. Yeah, just one recommendation that please do a comparative analysis with current existing plagiarism checking methods. Thank you.
Yeah, thank you so much.
Dr. Vandre, any questions for our speaker?
Yes, Asmita, very good topic that you selected. It's very much required. I just want to know, you said like word to word plagiarism you're going to do, right? So, how about the common words that are used?
Mm, can you just elaborate a bit?
How about the common some words we do use commonly? So, do that gets eliminated while checking it with your technique?
Actually, we are pre-processing our text. So in that, we are removing most of such words. Like we are removing stop words, and we are also doing lemmatization. For example, if like let's suppose it's walk, walked, walking. So we are converting it into root words. So it's basically walk only for everything which occurs. So we are addressing it more in pre-processing stage.
Okay, so you are removing such kind of words in pre-processing itself.
Yeah.
So what would be the time complexity in that case? Will it get increased by some uh, amount of time?
Hmm. The time complexity in this case.
Because pre-processing of that text would take some time, right?
Yeah.
So please do work on that, because nowadays all solutions are there, but we need optimized solutions. So if possible, try to work on that.
There's a linear complexity for stop word removal, O of n,
Yes. Okay.
because we have to see each and every word and then we have to just remove stop
Yes.
words.
So my suggestion would be just to work on it, right?
Yeah. Thank you.
Yes. Thank you.
Okay, thank you so much for your presentation. Before moving ahead, I would like to announce all the presenters who had missed out on their presentations. So give me just a second. Yes, so our first presenter was Arpita. Are you present in this meeting? Okay, she was not here. Second was Sharayu Mirazdar from the DES Pune University.
Yes, sir. Good morning. I'm here.
Oh, okay. Great. You can start presenting, ma'am, please.
Okay, fine. Yeah. Just a second. I'll just share my PPT.
Sure.
Yeah. So are you able to see that?
Yes, ma'am, your PPT is visible and you are audible as well, so you can
Okay,
start.
fine. I'll start. Okay, good morning, everyone. My name is Sharayu. My paper ID is 1234, and the topic is Ayurkosh dataset, which is machine readable Ayurvedic knowledge graph for computational intelligence. Now we know that Ayurveda is India's ancient system of medicine. So multiple treatises or grantha, which is scriptures, they are written in Sanskrit like Charaka Samhita, Bhishaj Ratnavali, Dravya Guna Sangraha, and etc. Now, if we look at the contents of that, they are not just historical writings, but they are centuries of collective clinical observations from multiple people and pharmacological trial. And basically, it is focusing on community health activities. And all these grantha, they have a huge interconnected knowledge about diseases, symptoms, herbs, and herbs which are used to treat these symptoms. And I have just given one example from Charaka Samhita. These are the shlokas. So as said here, the text which are written in these granthas, they are mostly unstructured and cannot be readily analyzed computationally. Now unstructured means we know that Sanskrit is structurally very perfect language, but when we look at computational analysis of these things, then we can say that it is difficult. That's why we have created one Ayurkosh Grantha, which is a machine readable, high quality Ayurvedic data set, and it is designed as a knowledge graph. It is used to support artificial intelligence driven research, so multiple researchers can make use of this data set. And what is the content of the data set is, it is subject predicate object triplet. In this form, the data set is constructed, and on this we can do multiple semantic interoperability operations. Graph traversal is possible, and graph traversal with the help of multiple hopping. This is what is done here. Now this data set is designed in such a way that direct schema can be built from this data, and a knowledge graph can be constructed from the selected entity or all the entities and relationship which are mentioned in this data set. Okay. So what this data set is, it shows a real world biomedical network characteristics like high sparsity. So I will be explaining about the graph statistics. So it shows high sparsity and low average degree. And these are the entities which are mentioned in the data set, and these are the relationship names. So we can say that all the biomedical NLP entities are written here. So the entities like diseases, which is called as vyadhi, then what all symptoms are seen when a specific patient is going through a specific disease, then what herbs are used for the treatment of these symptoms, it is also there. And quality of that herb, because also family group that herb belong to, and alternate herb. Now we know that Ayurveda do not treat every person equally, but every person has unique prakriti, and according to that a patient has to be treated. That's why this alternate herb is very important, because every herb may not suit the prakriti of every patient. So we should have a alternate herb also, so that is also available in the data set. Then compound means, like we know, chawanprash, so it is a combination of multiple herbs. So likewise multiple compounds are available and mentioned in all these Ayurvedic treatises, so they are also mentioned, and along with that references means from what this data or where this data can be found, that is also mentioned. Now all these entities are connected with each other with the help of multiple relationships. So disease has symptom treated by, herb has property and it belongs to, or what is the alternate herb of this herb, all these things. So this is how the data set is constructed in Sanskrit and English, and we have ported that on IEEE data port, and it is live there. The use of this can be made by academic and non-commercial research purpose. This data set is available, and as I told you, this is the direct schema can be constructed and knowledge graph can be constructed from this data set. Now, as I told you, coming to the data set statistics, so we have not just created the data set, but we have performed some statistics on that. Now, the knowledge graph, which is constructed from all the entities present in the database, we can see that number of vertices, because graph is represented like V comma E. So number of vertices are 17,159. These many entities are there, and the relationships which are formed in them are around 46,000 plus. Now, if we calculate graph density based on this graph with the help of formula, it comes out to be 0.0001566. So if we look at the figure, we can see that this graph is very, very sparse. And basically, mathematically, this is expected in real biological knowledge graph. Because see, why sparse graph is required? Because we know that all entities will not be connected to all other entities. It cannot be a dense graph. So when I take specific herb, then that herb will not be used for the treatment of all the diseases. Or if some symptom is there, that symptom will not be seen in all the vyadhis which are seen, right? So that's why it is the characteristics of a graph should be sparse if it has to be a biological knowledge graph. Okay, so that characteristic is shown here. Then now multiple queries will be there. So hopping is required whenever a direct relationship is there. For example, if I just want to find out what all symptoms can be seen in a specific disease, then that I can say it can be found immediately in 2 hops. So here we have also calculated the numbers which will be shown, means cipher query when it is fired on the knowledge graph, how many hops are required. So if it is a straightforward query, the after 2 hops the outcome is coming as 7.24, means around 7 nodes will be connected when I perform 2 hops using cipher query. If 3 hops are done, means when indirect relationship is there. For example, what formulation is used to treat amvat? So amvat is my symptom. It is not directly connected to the herb. So I have to perform hopping for that. Then 4 hops means disease herb substitute. So if we look at the nodes which are getting connected, as I increase number of hops is also increasing. So this is what is the expected behavior, that as I go into deeper and deeper into the graph, then the number of nodes which I can cover will also be increased. Now this is how the now this graph is constructed using Neo4j Aura, and this is how it looks like. So 17,159 entities are there, and we can fire cipher query on this, and it can be 1 hop, multiple hops will be there, and I will be getting the output. And these are the relationships, whatever 46,000 plus relationships are there. They are disease herb symptom or herb group, or this herb is used in what culp. According to that, the data set is arranged. So these are multiple relationships which can be found in that data set. Now coming to the applications which can be used here is the data in this knowledge graph is expressed in the form of graph. Okay,
Excuse me,
and
ma'am.
yes.
Nothing. Just a small reminder. You have 2 more minutes left. Thank you.
Yes, I'm about to finish now. Yeah. Okay, so the data which is expressed in the form of graph, it can be used by graph neural network. So multiple graph neural network algorithms can be applied on that. And also it can learn the patterns of relationship. Now here, one more thing is, if we have some existing compounds, but if I want to form a new compound, so that is nothing but a prediction of herb synergy. So that compound, what we will be done is, a cipher query is will be designed in such a way that for that specific person, what is the prakriti of the person and what should be the characteristic of the herb. So these queries can be fired, and a new prediction of a new compound which is called as culp, which is combination of herb, it also can be retracted from the knowledge graph. Also, this can be used for Ayurvedic education visualization. As it is a graph, it can be very much simplified, and it will be used by the students who are learning Ayurveda. Multi-hop clinical decision support system also can be built, and we have also built one semantic question answering, that whenever from front end some question is given, the query will be fired accordingly at the back end, and the answers will be found with the help of multiple hops on the given graph data set. Thank you so much. No, I'm not able to hear you, sir.
Can you hear me now?
Yes, sir.
Okay. Thank you so much for your presentation.
Yeah.
Professor Rana, do you have any questions for our speaker?
Okay, thank you for this fascinating presentation. Also, your work is very impactful.
Thank you, sir.
Say that, I should mention that. It's very, I hope that in the future, the researchers use this data set to find different insights.
Yes, sir, because I have within 3 months, I have got more than 400 plus visit, and downloads are also there, and I'm getting queries also from the researcher, and I'm sharing data set with them also who are not able to download it.
So this is expected, like you
Yes.
are doing you did a very impactful work.
Yes,
so thank
sir.
you for that. I hope in future you get a lot of citations.
Yes,
That's it.
Thank you so much.
Yes, thank you. Thank you too. And that's it for me. I don't have any questions.
Okay. Thank you, sir. Dr. Vanzare, any questions for our speaker?
No. Very good presentation that I found from today's session. So
Thank you so
no
much,
questions
ma'am.
from my side.
Thank
Yes.
you so much. Yeah. Thank you.
Okay. Thank you so much for your presentation, ma'am. That was
Yes.
quite an interesting topic.
Thank you, Amok. Thank you so much.
Hello. Sir, good morning.
Hello.
Yes, sir.
So actually there was a
Sir, please.
problem. So should I start?
Sir, just a second. We have one more speaker lined up before you.
No problem, sir. No problem.
Okay. Thank you. Yes, Purva, ma'am.
Sir, please try to exit me from that meeting. I am unable to exit. Then I will rejoin with seeing chat.
Can you repeat what you said? I couldn't get you. Okay, I think she has left. Dr. Kokane?
Yes, sir. Yes, sir.
So you can start presenting meanwhile, because she is facing some technical issues.
Okay,
So
no
yeah,
problem.
the next presentation will be done by Dr. Chandrakant Kokane, and the title of the research paper is Lightweight Machine Learning Models for Resource-Constrained Environments, Accuracy, Efficiency, and Trade-off Analysis. Sir, you can start presenting, please. Thank you.
Yeah. Very good morning, all. Very good morning, session chairs. So I'm Dr. Chandrakant Kokne. So my research paper title is Lightweight Machine Learning Models for Resource-Constrained Environments. So basically for the accuracy, efficiency, trade-off analysis. So this is the outline of my presentation. We have the introduction, motivation, objectives, literature review. Then proposed methodology, evaluation parameters we have, results and discussion, conclusion and future works. So let's start with the introduction. So basically we are having the traditional machine learning model. So here we are proposing the lightweight machine learning model. So basically the lightweight machine learning models are widely used in edge devices where we have the resource constraint. We have the limitations of resource constraint here. Okay, so basically the application domains we have in the healthcare, automation, sensing, and what we can say the IoT devices we have that we need to compute the resources over a user space. As we know that in the cloud computing we are having the user space and cloud space. So most of the computing is done at the server side, at the cloud space. So here we try to design the lightweight machine learning model which requires the high computation is expected with a low memory and low power resources. So the constraint we have the edge computing devices, that the edge devices operates with limited processing powers, where the memory we have the very limited memory, and we have the we have the battery, but the limited battery should be used for that processing purpose. So this is the general idea about the the tiny machine learning models, or we can have these lightweight machine learning models. So in diagram figure number one, we are having different devices where we have the limited memory on, as we know that on the smartwatches the battery powered is limited. We have the real time constraint as we are having the CCTVs. So just by considering the overall approach that we are proposing the lightweight machine learning models here. So the main motivation model, the model we have, as if we are talking about the text processing. In the text processing, suppose my mobile is taking the text, and that if I need to process it with a polysemy words, with the homonymy words, with the categorization of the words. So there is one data set named is OMSTI, that is the 1 million sales tag instances. So this data set is, the size of this data set is 4 GB and requires the huge amount of resources for the computation. Just by taking that what we can say drawbacks of traditional machine learning models, we have we know the growth of edge computing. We have the rapid adaptation of edge devices with respect to the traditional machine learning models. Then the limitations of cloud-based machine learning models, as everything that the computation was done at the cloud side, and as we are having the limited vendors too. So the computation is done at the server side. So there is the problem of latency, bandwidth dependency, obviously, and the privacy constraints. So just by taking that into the consideration, then the resource constraints, as I told you that we have the limitations, memory limitations, we have the computations power and energy capacity, we have the inefficiency and traditional models, that the traditional deep learning models and machine learning models are too heavy at it requires the huge processing times, and it is what we can say the challenge for the real time edge devices, or for the edge deployment we have. Just by considering this, the many applications require the instant response with the cloud reliance. So they want the as user is not interested whether you are doing the computation at user side or cloud side. So just by considering this, these are the objectives to analyze the lightweight machine learning model. First we have four different models that we have analyzed, then we have evaluated the performance. So here the most important thing is that the performance is not evaluated with respect to the accuracy, but the latency, memory usage, and energy consumption is also taken into consideration. We have the study accuracy with respect to the time trade-off, time efficiency, and accuracy trade-offs. And then the comparative models we have here, basically we have the linear models, tree-based models, neural network models, or tiny neural network models that we have analyzed. So within 1 minute, I'm going to conclude this literature review. So basically the resource constraint environments, what do you mean by resource constraint environment? So where we have the advantage of the enables the real time, what we can say the real time streaming on the devices from the remote locations. But the problem is here that the server constraint restrict the complex machine learning models for the deployment purpose. So linear and probabilistic models we have, yes, we can go with the linear probabilistic models here, but for the linear probabilistic models, then the fast advantage we have, that the fast training and the interference we have, and the low memory usage is required. But limitation we have, that the limited ability to capture complex non-linear patterns. So it is not able to if you are talking about the complex network approach where the data is represented in the form of edges and vertices, so this model fails. Tree-based model, as it is the non-linear data structure, so data is represented in what we can say the hierarchical, what we can say the rule-based approach or rule-based manners we have, where data is represented in the form of nodes, tree, so what we can say the nodes. So here we have the advantage of the captures non-linearity with moderate cost. But here the problem is that if we are going to grow the complex network, so if it is not controlled, as I told you, for the data set, if I need to represent the data set whose capacity is 4 GB, so it is very complicated to organize that data. Next, we have the shallow neural networks. So balance between, so advantage is that it provides the balance between accuracy and efficiency, but there is a low experience or the power, what we can say. Next, compressed deep learning models. So this is advancement in the deep learning. We have the compressed deep learning models where the hidden layers are limited. So just by reducing the number of hidden layers, we are having the advantage of it enables the deep models on edge devices where the resource constraint or the computation is what we can say, the computation power is less, but the possible accuracy, again there is a problem of accuracy if we are going to reduce the total number of hidden layers. Then the model comparison techniques we have. Okay, so moving forward, so tiny machine learning models we have, then the existing research focuses is on the improves specific performance aspects with respect to the resources, with respect to the available resources, with respect to the available what we can say the constraints. But just by analyzing this, what we identified that we have the approach of the multi-objective evaluation, as we are having the different what we can say the feature extraction techniques, we have different pre-processing techniques. Then we are not talking about only the accuracy, we have the latency, we have the memory, we have the energy together. And advantage is that the proposed hybrid approach is having that the need for the real world deployment decisions, and the limitations is that what we can say the limited comprehensive comparative studies we have. So just next we are having the proposed approach and the contributions. So the lightweight machine learning models, as they are going to focus is on the efficiently on resource constrained devices. Next step, we have the optimization objectives that we need to take care of these things, that is accuracy, latency, memory. Evaluation approach, we have that the performance evaluation is done with respect to the with respect to different state of the art lightweight machine learning models, the families. Then the structured taxonomy, where the classify the lightweight machine learning models based on decision and efficiency characteristics. Evaluation framework we have, then the evaluation is, then the performance evaluation is done with respect to multiple metrics to access the overall performance. So here we have the methodology here. So as here we can see the four machine learning techniques from the ML family that is analyzed, that the linear models, tree-based models, shallow neural networks, and compressed deep learning deep model. So this is the proposed what we can say the compressed deep model. So if you are going to observe here, the linear models is having the low latency, low memory required, but it's simple and interpretable, whereas the tree-based model is having the moderate latency, non-linear modeling is required, and limited depth we have. That is the what we can the limitation, limited depth. If it is growing, then it is very problematic to identify the nodes from the root node. Then the shallow neural networks we have, then the moderate resources are required for the shallow neural networks. It is applicable for the non-linear patterns, and but the problem of careful tuning we have for the training and testing for what we can say the activation functions again. And the compressed deep learning model we have with a high accuracy, then quantization and tuning is done here. That we can have the advantage here, and the what we can say the higher overhead is for the feature we have. So just by having the methodology, then the model wise approach here, the lightweight machine learning model focuses on analyzing the model designed for low consumptions and resource
Excuse me,
efficiency.
sir.
Yes, sir.
Just a reminder, you have 2 more minutes left. Thank you.
Okay. Yes, thank you. Then we have the model-wise approach. So, here is the important thing. We have the key methodological insights. We have the trade-off strategies, optimization approaches, and deployment focuses. So, basically, the deployment focuses by considering the real-time age, that is real-time devices, real-time information is considered here, and the embedded system. What we can say the deployment focuses we have. So, one more approach we have, that this app is applicable for the CCTVs, where we are going to deploy these tiny models in the CCTVs, and we can get the what we can say sentiment analysis of the person, sentiment analysis of the student. So this is the main motivation behind this topic. Evaluation is done, evaluation matrices. So I just want to focus on the data sets. So existing data sets, as I told you, that the OMSTI we have, that the 1 million sense tag instances we have. So this is very problematic if we are having the large data set. So we are not getting what we can say the processing time is required high for the data sets. So here basically two data sets that I need to mention here IMDb dataset we have, which is a small medium text dataset provided by the Google. And for the IoTs, we have sensors datasets that we require. And the most of the applications we have here that it requires the less memory computations and faster training and interference is there. And here the most applicable models we have that the mobile net. So hardware requirements we have that is yeah, experimental setup and models. So linear models with respect to the logistic regressions. So baseline models with high efficiency and low complexity. The decision tree that the depth is limited. If we are having the limited depth, then we capture non-linear with controlled resource usage. We have the random forest shallow neural network, and this is the proposed that is the quantized CNN, which is convolutional neural network. So I would like to mention one important point here. Recently there is an advancement that is a graph-based convolutional neural network. So this is the just what we can say the optimized model from this graph-based convolutional neural network, that is quantized neural network models we have. Then the results and discussion with respect to the accuracy. So the best performance we are getting here, the highest model complexity improves the accuracy. So linear models, tree-based models, and the image task. So basically how as image are taken, this model is what we can call it as a hybrid model, applicable for the images, applicable for the text. Okay, we have that pre-processing, we have then the segmentation, we have the feature extraction, then we are having the classifiers. Here we are just talking about the classifiers. Okay, so next moving forward, we have the efficiency analysis we have, then the linear models, decision trees, shallow neural networks. Then the quantized convolutional neural networks, which provides the high computational cost, requires high computational cost, okay, with despite of model size. Trade-off analysis we have, then trade-off visualization, results that I need to visualize. So if you are going to observe this figure 2 represent the accuracy comparison of lightweight machine learning model based on by using the data sets here. So we are getting the highest accuracy. Here we can have the logistic regression, decision tree, random forest, and shallow neural network. So here we can say we are getting near about 89% of accuracy for this image classifications. So the accuracy with respect to the different parameters we have, then the inference latency, we have the memory usage. So the decision tree is having less memory. Okay, here we can have the analysis of the decision tree is having requires the main memory, whereas the shallow neural network is having the low inference latency we have. So just by observing these accuracies, so here we have the conclusions, the comprehensive analysis, accuracy, linear models, tree-based models, shallow neural network, and compressed deep neural. Just by analyzing these, the final what we can say, the conclusion is that the optimal model selection should be balanced with respect to the accuracy and resource constraints. So here we are not going to conclude that this model is best or this is having the advantages, but with respect to the constraint, or with respect to what we can say the data set, with respect to your resources, so that is applicable. So these are my references, and thank you, team ICTS. Over to you.
Thank you for your presentation, sir. Professor Anna, do you have any questions for him?
That was a very nice and insightful presentation.
Thank you,
Thank
sir.
you on that. And I have a query. I think you already mentioned that, but I would like to know that thing. So the query is based on your findings. Let's say if a developer is working with an extremely power constrained wearable, suppose a smartwatch with a very limited battery.
Okay.
So, according to your work, which specific model or compression technique provided would be most efficient in this scenario?
Okay. Sir, if we are talking about the smart watches where we have the limitations of power, where so many parameters that we need to constrain here. Resource constraint we have,
Yes.
the limited resource constraint, limited power we have. So for this, that the compressed deep neural network model, that is the quantized convolutional neural network model, is best for the watches, not for only smart watches. It is applicable where we have the limited resource constraints, limited power, and limited processing. So I think this quantized CNN model is best for such a devices or for such applications, sir?
Is this calculated based on just the constraints or the accuracies and other parameters also? Let's say a model performs very fast and consumes very less energy, but the accuracy is not that good, but a model is very accurate, but this is the trade-off, right?
Yes, 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 sir.
This is what we are talking about. So the thing, the tip model you mentioned, the is what is that perfectly balanced or it is skewed in some constraints?
Yeah, actually, sir, I would like to mention one point here. Whenever we are going for the text processing, as I told you, for the text processing,
Yes.
again, we are getting the models are performing best, but there is a problem of accuracy because for text processing we are having the homonymous and polysemous word. So that model is not able to handle that the lexical ambiguity. There is one problem with text processing. So for such a models, this quantized CNN that we have tested, and this quantized CNN is using that BERT, that is bidirectional encoder representation from transforms. We generate 768 dimension word vector. So it is just balanced. If we have the resource constraint, if we have the accuracy, if we have that the power, what we say, power consumption that we need to take in care, then this is just what we can say the balanced classifier we have. That is a complex deep model with quantized CNN, sir. This is completely tested.
Okay. Okay. So I think I have my answer. Thank you. Thank you for your
Thank you, sir.
presentation.
Thank you.
Thank you for presenting, sir. Dr. Vanjali, do you have any questions? Okay, I think she is away from keyboard. No worries. Thank you so much, sir, for presenting. So yes, so the next presentation is so the next presenter is Arpita Chaudhary from the National Institute of Technology in Silchar, India, and the title of the research paper is a hybrid CNN RNN framework for audio-based bimodal authentication. Ma'am, I request you to start presenting, please.
Hello, good morning to everyone. Am I audible?
Very good morning, ma'am. You are audible.
Please give me a second to share my screen.
Sure.
Yeah, I'm not finding the slideshow mode actually. Can you?
Just give me a second. If you can close the All Tools menu on the left side of the screen, please.
Yeah.
Yeah, just yeah. I think you can present it this way. It's not a problem.
Okay.
Okay. Thank you so
So
much. You
it
can
is
start.
visible, right? Okay.
Yes, it's visible.
Okay. So I'm going to present my paper. The title of the paper is a hybrid CNN RNN framework for audio-based bimodal authentication. I'm Arpita Chaudhary. I'll be presenting the work, and my co-authors are Pinky Roy and Professor Shivaji Bandyopadhyay. Me and Dr. Pinky Roy are from Department of Computer Science Engineering, NIT Silchar, India, and Professor Shivaji Bandyopadhyay is from Department of Computer Science and Engineering, Jadavpur University. So this is the outline of our presentation. We will start with a brief introduction. We will show some related works, and then we will go straight to our methodology. We'll discuss the result that we have obtained in this research, and we will conclude the presentation then. So, to begin with the introduction, we all know that traditional authentication systems are generally single factor authentication system. Single factor, we mean we generally use username password combination where the user must remember the password, or we use face recognition, iris recognition, fingerprint recognition, etc. However, these single factor methods are often vulnerable to attacks. Why? Because in case of, say, username password combination, If there are weak and used passwords, they are easy to guess, and phishing attacks are very common in such cases. For if we intend to keep strong passwords, it reduce the usability, because those passwords are sometimes hard to remember. Again, OTP verification, which is very common these days. So it is seen that OTPs are also getting stolen through social engineering attacks. In case of face recognition, there are issues like deepfake spoofing nowadays. Again, for fingerprint authentication, a limitation is that we need to use our hands for it. So it's limit the user convenience. So a solution for this can be multi-factor authentication, where the security will be enhanced using multiple factors at a time. This is why we proposed speech-based multi-factor authentication. Why speech-based? Because we know that human voice exhibits unique speaker-specific characteristics due to due to the anatomical reasons. And why not why speech-based, and why not uh, other what should I say, modalities that we will see in our following slides. So due to the unique characteristics of speech, as we already told, that we were motivated to develop a speech based multimodal authentication. So for that, we took with the same modality, that is with speech, we took two different aspects. One was spoken OTP recognition. In that case, the spoken OTP will be converted to text to check whether the OTP matches with the OTP received by the user, and also the speaker's voice will be recognized. So in this way, it is a our developed model is a bimodal speech-based authentication system. So these are some references where we can see that in past years, and it started from uh, like far back, say from 2005, where research works on multimodal authentication started. We can see that people worked on fingerprint and face modality. Even teeth images were found to be unique and used for bimodal authentication. Similarly, keystrokes behavior, mouse stylometry, PPG, ECG, etc., were also found useful for multimodal authentication. Also, several deep learning models were used for these systems. For example, in the paper Bion et al. That was published in 2024, we can see VGG16, ResNet 50, and DenseNet 169 models were used. However, we know that these models are quite heavy quite computationally complex. So for our work, we used AudioMnist corpus. It is a audio data set. It originally contains English digit utterances from 60 subjects. But for our work, we took a stratified subset of this data set. We took 10 subjects out of the 60 subjects. We took 10 subjects. Out of these 10, 5 are men, 5 are women, and these 10 subjects have, all of them have different accents. So in OTP based authentication system, we know that the passwords are generally 4 or 6 digit long sequences. So in our original data set, we had audios which contained a single digit utterances. So we concatenated them, and we defined 20 fixed 6-digit sequences for training our models. After selecting the data set from the original audio MNIST data set, and then uh, concatenating them to create OTP digit sequence, we perform data augmentation. For data augmentation, we took three audio augmentation techniques. These are noise superimposition, volume scaling, and speed perturbation. So for noise superimposition, we took babble noise. So babble noise is that kind of noise when in the background multiple people are talking, but it is not perceivable. Then we call it babble noise. So it is generally seen in our day-to-day life. Generally, such kind of noise are observed. That's why we chosen babble noise for our work. So we superimposed babble noise with clean speech signals at different signal to noise ratio. These signal to noise ratios, the five selected signal to noise ratios are -5 dB, 0 dB, 5 dB, 10 dB, and 15 dB. So -5 dB means most noisy, and 15 dB means less noisy than like it's we can't call it least noise, but it's still perceivable. For speed perturbation, the speed of the audios are increased up to 1.5 times and decreased up to 0.5 times from the original duration. Similarly, again, for volume scaling, the signal amplitude is adjusted by applying a gain in the range of 5 decibel to 12 decibel.
Excuse me, ma'am.
Yes.
Just a reminder, you have 2 more minutes of presentation time left. Thank you.
Okay, fine. I'm concluding soon. Okay, so after preparing our data set and the data augmentation, we extracted MEL spectrogram from the audio. Why MEL spectrogram? Because we know that human auditory systems follow MEL frequency scale rather than linear frequency scale. So once we have the MEL spectrogram of all the audio, first, for the speaker recognition part, we fed the MEL spectrogram for training to a MobileNet version 2 network. So, this what we have done for the speaker recognition, and for the speech recognition, as it is a sequence data. So, MobileNet V2, what it does, as it is a CNN based architecture, it extracts only spatial features. So but for sequence data we need temporal information as well. So what we have done, after extracting features from MobileNet V2, we have fed it to a bidirectional LSTM, and for sequential data we used CTC loss. So with that, so this is the system diagram for our speech-based bimodal authentication system, where, as we already mentioned, the server will send the 6-digit OTP to the user. So first, the voice of the speaker will be recognized. If the voice matches with the original speaker, then only we will go for OTP recognition. And if finally the OTP is recognized, OTP matches, then access will be granted to the user. So we conducted the experiments on the Kaggle platform with the 16 GB of T4 GPU and 13 GB of RAM. So our data set was divided into three parts: training, validation, and test set, in the ratio of 80:10:10. Also, we have independently run the training 3 times, so that we can make sure that the results are not obtained by chance. And for evaluation, we used two parameters: accuracy and character error rate. So for speaker recognition, we achieved an accuracy of 98.83%, which is it's an average accuracy over 3 runs. So it is a good accuracy we can claim. as we have pre-trained our OTP recognition model with the isolated digit data recognition. So for that isolated digit data recognition, we achieved an accuracy of 99.5%. So for comparing our models, we used three other architectures where we replaced BiLSTM with bi-gated recurrent unit, plain LSTM, and plain group. So we achieved, this is the tabular format of our results. So we saw that our proposed model, which used MobileNet along with BiLSTM, achieved higher accuracy and lower character error rate. So we can claim that among these four, our proposed method worked the best. However, what we noticed is that when we test the model with any digit sequence with which the model was not trained, the accuracy decreases and decreases up to 87.9%. So although we need to improve that, so still we can claim the efficiency of our model, as the framework requires very less flops, that is 0.237 flops for each forward pass, and the inference time of the model was 280.25 281.25 millisecond, which is also lesser than heavier models like VGG, ResNet, etc. So we would like to conclude our presentation saying that the deep learning approach that we proposed for bidirectional, bimodal uh, authentication system with MobileNet v2 and BiLSTM with CTC loss performed well for 6-digit OTP recognition task along with speaker recognition task. However, we can fine tune the model on larger and more diverse data sets. In future, we are planning to compare our work with more with other CNN based alternatives such as ResNet, VGG temporal CNN, and transformer based architectures. Also, evaluating the model on edge hardware to analyze latency, memory consumption, and real time performance is a plan of our future work. These are the references of this presentation. So I'd like to thank you. And if
Thank
there
you
is,
so much for your presentation, ma'am. Professor Anna, do you have any questions for our speaker?
Okay, first of all, thank you for a very clear and methodical presentation, Arpita.
thank you, sir.
I have one question for you, which is in your methodology,
Yes, sir.
you mentioned that you used a pretend MobileNet v2,
Yes,
right?
sir.
And before passing them to the BiLSTM modeling.
Yes, sir.
So given that the audio signals have a very different structural nature compared to the ImageNet images, the
Yes, sir.
dataset that the MobileNet was originally trained on.
Yes, sir.
So my question is that did you find that fine-tuning the special backbone was necessary, or were the generic feature extractors were sufficient for distinguishing between similar sounding digits?
I understand, sir. So actually, what happened, although I have not included that in the presentation, so traditional speech recognition techniques use MFCC features which require different sort of processing. So when instead of MFCC, I converted it to MEL spectrogram, which then becomes image representation. So for that, when we tried spatial feature extraction with MobileNet, we did not use the weights of ImageNet. Rather, we extracted features from scratch. So we found that the results are impressive, and although the original task for which MobileNet was trained, that was with the ImageNet data, but for audio as well, it is performing quite well. So it is for spatial feature extraction of the MEL spectrograms.
Okay, thank you. And I have a same recommendation for you as everyone that you should compare your work with current studies that have been done since now. That's it. Thank you.
Sure, sir. Sure, sir. I'll conduct that in the future. Thank you, sir.
Dr. Vanzare, any questions for our speaker?
Yes, Asmita, very good presentation. I just want to know, like on in case of audio, you have considered, right?
Yes,
So
ma'am.
what the files that or the what are the types of the files that you will be considering? Any specific
Mm,
or will be okay for your system?
Ma'am, the data set that I have used, AudioAmnist, it had .wav audio files, but when I trained the model, as I have converted the audio files to MEL spectrogram images, I trained them with uh, image files with .png extension.
And like only .png, like you will be
Yes, ma'am,
considering
but it will work with any
any
general
audio.
image extension that is known to us. It will work on JPEG and other such uh, image formats.
Okay, okay, no issues. That's it from my side.
Thank you, ma'am.
Okay, thank you so much for your presentation, ma'am. We can now move on to the next one. Give me just a second, which will be done by Ambati Abhinavya from the National Institute of Technology in India. And the title of the research paper is Wavelet-Driven Intelligent Model for Multi-Class Breast Cancer Diagnosis. Ma'am, if you are present, please can you start presenting?
Good morning, sir.
Very good morning, ma'am. Purva ma'am, can you unshare your screen, please? Okay, no worries, no worries. It's done. Thank you.
Good.
Yes, ma'am, you can start presenting.
Okay, sir. Good morning, everyone. I'm Abhinavya from National Institute of Technology, Warangal, and the title of my research work is Wavelet-Driven Intelligent Model for Multi-Class Breast Cancer Diagnosis. And the contents of my presentations are introduction, then literature survey, motivation, objectives, methodology, conclusion, future scope, and references. Introduction. Breast cancer is a disease characterized by the uncontrolled growth of abnormal cells that form tumors within breast tissue. According to World Health Organization report published in 2022, approximately 2.3 million women were diagnosed with breast cancer worldwide, with nearly 670,000 deaths reported globally. And women are significantly at higher risk, accounting for nearly 99% of all breast cancer cases, while male remains very rare with 0.5 to 1%. And the burden is even more critical in low human index development countries, where nearly 1 in 27 women develops breast cancer during her lifetime. So, therefore, early and accurate diagnosis plays a crucial role in improving survival rates among the breast cancer patients. Sorry. And breast tumors are broadly classified into two types, benign and malignant. Benign tumors are non cancerous and they do not spread to other parts of the body and usually grow slowly. But early detection is equally important, though they are less harmful, but sometimes they require monitoring or removal of such lesions. And malignant tumors are cancerous. They have ability to invade into the surrounding tissues and spread to other parts of the body. We usually call it as metastasis stage, making them life threatening. And ductal carcinoma, papillary carcinoma, mucinous carcinoma, and lobular carcinoma are the most common malignant subtypes. And among these, ductal carcinoma and lobular carcinoma are most commonly observed subtypes. Fibroadenoma, adenosis, phyllodes tumor, and tubular adenoma are benign subtypes. In this research work, I have concentrated on these 8 subtypes. Coming to the literature survey, this table presents a summary of existing methods for breast cancer classification. It includes uh, the methods and the performance uh, of the existing works. From these existing studies, it is observed that majority of the intelligent systems emphasize the binary classification separating benign from malignant. But subtype categorization has not yet done, like using feature extraction techniques, though it is vital as it provides deeper insight into tumor characteristics and disease prognosis that further enables more precise and personalized treatment planning. So, taking this as a motivation, the high prevalence of the breast cancer and critical need for early, accurate, and subtype level diagnosis motivates the development of such automated classification systems. And the objective of my work is to identify the different types of breast tumors and to enhance the classification accuracy using wavelet decomposition technique and classifying using artificial neural network classifiers and machine learning algorithm to ensure efficient and consistent diagnostic approach. This figure shows the workflow of the proposed method for breast cancer classification system. The process begins with the BREAKHIS dataset, which contains histopathology images of breast tissues, including both benign and malignant cases. In the pre-processing stage, the images are resized to a uniform dimension and the noise is removed to improve the image quality. Next, the features have been extracted using discrete wavelet transform. This helps in capturing spatial and uh, spatial coefficients from the images. And the statistical features such as standard deviation and energy minimum and maximum are extracted to effectively represent the texture characteristics of the tissue. These extracted features are then fed into different machine learning classifiers and artificial neural network classifiers uh, for intelligent classification. And the system performs two types of classification. First one is binary, which distinguishes between benign and malignant, and second one is multi-class classification to identify specific subtype of a breast cancer, either it is benign or malignant subtypes. And then the performance of the model is evaluated using medical statistics such as accuracy, precision, to assess their effectiveness. And then the model and the system produces intelligent diagnostic outputs, including whether breast cancer prediction, subtype identification, and then comparison of all the three models used. The discrete wavelet transform, uh, three-level decomposition technique is used to extract features, and wavelet transform decomposes the image into set of coefficients using three-level decomposition technique, which is shown in the figure. Like at the first, I have used three-level decomposition technique, um and then and then extracted 22 features, and these features I have fed as input to three classifiers: MLP, radial basis function, and random forest. The statistical features that are extracted using this technique are maximum value of coefficient, minimum value of coefficient, and energy rate, and the standard deviation. uh, MLP, multi-layer perceptron, is a feed-forward artificial neural network It consists of one input layer and one output layer and number of hidden layers. It consists of multi-neurons or perceptrons in a directed graph, and the layers are fully connected to next one. These hidden layers are programmed as activation function. In the sigmoid function is used as an activation function. This architecture is used to classify the breast tumor. And second one is radial basis function. It is also a feed for artificial neural network. One input layer, it consists of one input layer, a hidden layer, and an output layer. It uses a radial basis function as an activation function. The third one is random forest algorithm. It is an ensemble method that combines the decision of multiple decision trees. It works in two phases. First one is to create the random forest by combining n decision trees. Second one is to make predictions for each tree created in the first phase. Once one of the example is shown in the figure 5, how the random forest works by taking the majority decision of decision trees. This is a comparison of three classifiers, and it is observed that a random forest achieved higher accuracy when compared to MLP and radial basis function. This is a performance evaluation with the existing works. The existing uh, the existing works differentiated the lesion into benign and malignant. Most of the works are concentrated on binary classification. In this, though this technique outperformed the existing works with 94% accuracy, and existing works were limited to binary classification, whereas this work extended to benign subtype classification and malignant subtype classification. It is observed that benign
Excuse me, ma'am.
sir.
Just a reminder, you have 2 more minutes left. Thank you.
Okay, sir. Okay. In the benign subtype classification, the random forest achieved higher accuracy when compared to MLP and radial basis function, and also in benign subtype and also in malignant subtype, random forest achieved higher accuracy with 92%. The proposed work enhanced the classification accuracy to 94, 97, 92% for binary, benign, and malignant subtypes. And these analysis the experimental results indicate that random forest classifier achieved higher classification accuracy and low computational complexity when compared to MLP and RBF classifiers. And the future scope is we can extend this for breast cancer alert system. Uh, Using a wavelet based feature extraction scheme for telehealth monitoring applications. These are the references. Thank you.
Okay, thank you so much for presenting, ma'am. Professor Anna, do you have any questions for our speaker? Hello, Professor Anna, can you hear me? Okay, Dr. Vanzare, do you have any questions?
Yes, the presentation was very good. I just want to know the data
Thank
set
you.
she has worked on, and what is the like why RNN, because it gives the better results that I understood. But what about the complexity?
Yeah, okay, ma'am. I used break his data set, uh, which is containing both benign and malignant subtype histopathology images. I collected it from Kaggle repository. And coming to complexity, manual feature extraction is becomes difficult when we go for large data sets. But the advantage of using such type of technique is when where the data set is uh, very small and like in remote areas, we can go for this technique.
Okay, okay, that's it from my side, sir.
Okay, thank you so much, ma'am.
Thank you.
We have one last presentation left for this session now. So the next presentation will be done by Purva Trivedi.
Am I audible, sir?
Ma'am, yes, ma'am, you are clearly audible now. You can start presenting, please.
Okay, sir. My topic of presentation is review of modern energy harvesting strategies, comparative insights, and performance evaluation. In this site, I included introduction, need of energy harvesting strategies, energy harvesting methods and technologies, non-conventional energy harvesting methods, conceptual energy harvesting approaches, interdisciplinary perspective on emerging energy harvesting methods, non-conventional energy harvesting methods, microwatt energy harvesting methods, conceptual energy harvesting methods, and conclusion and proposed work. Conventional energy sources such as coal, petroleum, natural gas, and nuclear fuel are inherently finite in availability, and in addition, their detrimental environmental impacts are largely irreversible. Consequently, reliance on alternative energy sources, including solar, wind, hydro, and thermal system, continues to grow despite the technical and practical challenges associated with their implementation discussed in this study. According to the International Energy Agency, global energy demand is expected to rise significantly by 2050. Air condition uses alone could triple, with nearly 10 units sold every second, placing substantial pressure on worldwide energy resources. To address this surge while maintaining environmental sustainability, researchers across the globe are investigating efficient and small scale energy harvesting solutions. Emerging energy harvesting technologies are piezoelectric system, microelectromagnetic generators, biobatteries, electromagnetic harvester, which is also known as rectinas, nano generator, and wearable energy devices. Energy harvesting technologies methods are categorized into two groups: non-conventional techniques, in which solar, wind, and hydropower included, and conceptual techniques, MIM diode and geometric diode. Energy harvesting methods and technology in unconventional method are sunlight energy harvesting, aeroline, which is wind energy harvesting, water-based energy harvesting. And in microwatt energy harvesting, thermal power energy harvesting is using electric material, microelectromagnetic energy harvester, and enzymatic bio fuel cell. Principle driven methods are advances in field of energy harvesting, radio frequency energy harvesting, geometric diode energy harvesting, and energy harvesting. This is solar harvesting energy system, non-conventional approach. This is wind energy harvesting system, that how we can generating use energy harvesting using wind energy power system. This is hydropower harvesting system. This is microwatt energy harvester types, thermal energy harvesting, piezoelectric energy harvesting, microelectric generator, and biobatteries. Conceptual energy harvesting approaches are two types: radio frequency harvesting and MIM diode rectenna. This is the conceptual and non-conceptual energy approaches in energy harvesting. This is on the basis of parameters like energy sources, availability, conversion principle, infrastructure, cost, output capacity, typical uses, efficiency, harvested power, lifespan, limitation, and commercial feasibility. And so different comparison has been made for solar, wind, thermal, piezoelectric, microelectromagnetic, biobattery, rectenna MM, and rectenna geometric diode. Interdisciplinary perspective on energy harvesting method to address anticipated future energy requirement. Government and private organizations worldwide are implementing policies and regulatory frameworks that promote research and development initiatives. Examples include the adoption of advanced building electrification technologies, tax incentives, and the installation of complementary charging infrastructure for electric vehicles. Furthermore, factors such as compatibility with existing energy harvesting systems, scalability, competitiveness, material longevity, and socio-economic feasibility represent key consideration in evaluating the commercial potential of these advanced EH technologies. Last, we concluded that energy harvesting technologies provide diverse solutions for sustainable power generation across scales, from micro devices to industrial plants. Each method has unique strengths and limitations, making careful selection essential based on application, location, and economic factors. Continued advances in material science, device design, and system integration are expected to expand the practicability and efficiency of these technologies, paving the way for broader adoption worldwide. Proposed work should focus on advancing individual energy harvesting technique as well as integrating multiple harvesting method into unified system or grids. Such developments could provide more reliable and versatile energy solution for diverse applications. Continued innovation and supportive policies will be essential to accelerate progress, ensuring sustainability and enabling practical commercial deployment for emerging energy technologies. Thank you.
Okay, thank you so much for your presentation, ma'am. I now ask our session chairs if they have any questions for you. Professor Rana, do you have any questions for our speaker?
Now, thank you. That was a nice presentation. I don't have any questions.
Okay, thank you so much, sir. Dr. Vandare, any questions? Hello, Dr. Vandare. Okay, I think she is not right now with us. Anyway, thank you so much for your presentation, ma'am.
Thank you so much, sir, and sorry for the inconvenience. Thank you so much.
It's absolutely fine. Okay, so that brings us to the end of technical session 10F. I now request Professor Rana to give us his closing remarks. Hello, Professor Rana, can you hear me? Hello? Oh, okay. Dr. Vanzare, do you hear me? Okay, no problem. So yes, I sincerely thank all our authors for their excellent presentations and contributions in this session, and all of our participants as well for being a part of this conference. I hope this session was informative enough for all of us. And on behalf of the entire team, I thank all of you for the support you have shown during this 11th version of this conference and all the previous versions as well. We will be more than happy to have all of you back in 2027 for the 12th version of this conference. A small announcement, all the presenters will be getting their certificates within 2 working days, and the publications will be live within 7 to 8 months. So kindly cooperate with the team of ICTIS. I also thank both our session chairs for chairing this session. Thank you for your valuable presence. And I now request every one of you to please turn on your cameras for a quick snapshot of this conference, please.
Yes, Amuk sir, can you please share that flyer?
Sure, sir. I will. I have noted the number that you put in the chat box. I will be doing it. Sure. Thank you.
Please, sir.
Yes, can all of you please switch on your cameras? Okay, thank you so much, everyone. Have a great day. And we will be starting with technical session 11F in 5 to 10 minutes.